multiplied by perpendicular distance of 10 inches. So this is equal to 1,500 pound-inch, and it's rotating in this direction, right? So we know that based on the moment, right, it's going to rotate in this direction, moment in Z. Right? So don't forget like what I taught you, right? This will be in tensile. The head will be under what? Compression. Right? So when you write this, right, element H, right, you can see down here. So you do this also. This is really important. Okay, so you can write in square bracket element, or you can just put H, right, will be under positive, which is tensile, right? And element K, right? So sorry. So stress X of element H, right, due to bending moment, okay, will be in tension, and stress X, on element K will be equal to 0, right? Because element K is on the what? Neutral axis. So again, you have to envision, okay, you have to envision the stress distribution. So due to bending, right, we due to bending. So this is stress X is equal to my over I, and this is your Y, right? So we know, excuse me, and we know that this is the distribution. So at this location over here, this is where your element H is. And in this location, this is where you have your element what? K. Right? So that's why element H is positive, element K is equal to 0. Now, these are the analysis that you really need to know. Okay, sorry, I draw them in the wrong direction. Okay, it should distribute this way. It's just a sketch. Okay. Okay. So that's why it's so critical that you have to envision your moments and your shear and your axial loading. Okay. So for px is straightforward. Px, we know that in this form is px divided by area. So everything is in tension, regardless of element H or element K. Okay. So now once we come back into this view, anything else to analyze? And the answer is no. Okay. Now question is this. We know that the 150 will induce a what? A moment. Okay. And why is that? If we were to draw the deformation pattern, okay, we were to draw the deformation pattern. So the green is our deformation pattern. Sorry, I'm going to choose this color. Okay. So due to the 150 pounds, this is the deformation pattern. And this is due to the 150, right? And I'm going to write this. This is the deformation pattern. Okay. So when you view that as a deformation pattern, if the deformation pattern is either at the neutral axis, okay, so this is the area of interest. This is the axis of interest. If it's smiling face or sad face, then it's under what? Bending moment. Okay, so I'll write this out. So when the neutral axis, yeah, I'll write this out. When the neutral axis okay, when the neutral axis deformation pattern all right, is either a smiling face or sad face, right? Then the applied force is inducing a moment. Okay, that's inducing a moment. So for this case, you can see based on the neutral axis, we're highlighting yellow is set face, right? Due to the 150 pounds, right? So we classify as bending moment. So now, once we see over here, any other forces to analyze? The answer is no. Why? Because for at this view, okay, looking at the XY plane, right, we only need to analyze the arrow. The dots and the cross, do not analyze them. Okay. Then the next thing is we're going to draw a different view. Okay, we're going to draw a different view. So I'm going to take the image again. Okay. Now I'm going to view in the plan view. Okay, so now look at our transformation. Okay, let me transformation. This is my X. This is my Z. Okay, and this is rotation about Y. Okay, so I'm going to draw a shaft again. So 4, 4, 4, 6. Okay, and this is our shaft. And then this is the again, this is the plan view. Okay, so this is the round bit on the top. Okay, right. Then follow the same rules. Okay, draw the position of your neutral axis. Okay, so this is your neutral axis. All right. So after you draw the position of the neutral axis, the next thing is you draw your elements. So this is your element. This is your element. So this is your element H. Over here, this is your element K. Right? That's done. Okay. Then next, you start drawing your forces. Okay. So you start drawing your forces now. So your forces. So we know that we have 150 over here pounds, right? And then we have a hold on. Let me. This is not very good for you to view. So we have a 150. We have one down here, and this is your 200 pounds. This over here is your 50 pounds, right? And then and then somewhere around here, you have your 150 pounds. Okay, so that is your structure. Okay, so now you look at this now, right? You can now you have to analyze all your forces now. Okay, you have to analyze all your forces. So I'm going to do this. We are going to draw our we're going to find our VZ. Okay, we're going to find our VZ. So VZ, so everything is relative to elements H and K. Okay. So now, by the way, I'm not doing static analysis. Okay. Why I'm not doing static analysis? I'm not saying summation about forces in the Y, X, Y, and Z is equal to 0. We did not do that. Okay. So everything relative to the element. So I will call this, okay, whatever that is going up, okay, is my F in my Z direction. Okay, so F in the Z direction, everything is relative to element H and K. So you have 150 plus by 50, okay, minus by 200. So this is equal to 0. It happened to be equal to 0. In fact, this is going to induce a shearing stress, a shear force in the Z direction. Okay, that is our shear force, right? So how to identify whether it's a shear or not? Okay, only the 150 is axial. Okay, the 150 is axial is because it's parallel to the what? It's acting on the neutral what? Axis. Okay, so I'll write this down. When the force is applied along the neutral axis, it is considered axial loading. Okay, it is considered axial loading. Okay, now, so you know that Vz is equal to 0. Then the next one is we have what? We have moments now. Okay, so we have moment in the y direction, right? So now, if you look at over here, right? When you calculate your moment, now when you calculate your moments, it's relative to the element, right? It's not relative to the what? Neutral axis anymore. So if you look over here, right, the 150 is going to 150. You have a distance of what? The distance from here to here is, if you look at our diagram, it is 4 inches. If you look at the distance from here to here, it is 6 inches. Okay, so now you take about the moment in the y direction. Okay, so it's up to you to consider whether you want which direction to be positive. Okay, so I'm going to do anti-clockwise to be positive. Okay, so summation about moment in the y direction for element H and element K, right, is equal to, so the 150 is going to do anti-clockwise. Okay, so it's positive 150 multiplied by 4. Okay, and then plus by the 50 multiplied by 10. Then the 200 is going to go anti-clockwise. Sorry, clockwise. So it's 200 multiplied by 10, right? So this will be equal to 150 multiplied by 4 plus by 50 multiplied by 10 minus 200 times 10. So it's equal to minus 900 pound-inch. So 900 pound-inch means it's going to rotate in this direction. Okay, so you can put down this is going to be 900 pound-inch, and this is going to be tensile, and this is going to be compression, right? So from here, again, you can analyze, you can do the analysis like, right, element H is going to be under tensile. Okay, it's equal to tensile. And element K, oh no, sorry, element H is not equal. Element H is going to be equal to 0 because it's on the what? Neutral axis. You can see that, right? It's on the neutral axis, right? And then you can see that in your element K, right, for your element K is going to be in the compression.